Good day. So, I'm going to explain you how a draining system works. What is it and what's the purpose? So, first of all, what is a draining system? A draining system is a set of pipes that has the purpose of extracting and pulling out the water and giving water to a place. In this case, it can also be from the ocean, from the sea, or even a dam, which contains clean water, from to a population. In this case, it can be an urban zone, a rural zone, a city, or a small town, etc. So, these pipes have worked since a lot of time. It can also be affected from our ancestors. So, these pipes affect in two principles, but mainly in one, which is the Pascal principle and the Archimedes principle. The Pascal's principle is the most important in this case. So that's why when you can actually push water from a pipe with just even more water, actually, you can actually make it to go from one place to another in certain speed. But it's something constant. That's why you can actually have water in your house just by this principle. Second of all, the Archimedes principle. This principle makes that the water can actually go down, or go up in a pipe. That's why you can actually have the pipes underground of your house, and that's why you can actually have water at the top of your house by just this principle, which makes the buoyant force make it go up or go down. That's why this is something important to understand in case you can actually have a problem with your pipes or in your water system in your house, to get an idea of what is working, how is it working, and you can actually not just help yourself, you can actually help other people who do not know. That's all. Thank you.
My name is Fernando, and I'm going to explain stage 2 of Physics 3, that is heat, most specific in the case of the measurement of temperature. Like how we're in Mexico, we use the Celsius. We have another kind of measurements like Kelvin or Fahrenheit, but Kelvin is more specific in another kind of problems in the science, and Fahrenheit is most used in USA. In this case, we have like the device that's in charge to measure the temperature is the thermometer, and in this case we are using this device to measure the temperature of the water. For example, the water, the 0 degrees is the point of freeze in the water and in the salt, and the point of boiling is 100 degrees. So in this case we have like 90 degrees in Celsius. But for example, a case that we use every day, for example, if you're a person of USA and you don't understand the Celsius degrees, you need to change or transform a problem to change the Celsius to degrees. No, the Celsius to Fahrenheit. So in this case, we use the 90 degrees and we need to multiply to 1.8 plus 32, and we have 194 Fahrenheit. But if you're other kind of person and you need the Kelvin, well, it's more easy in this case, because if you have the Celsius, you need just to add 273 to the Celsius measure. Well, we need to turn off the boiling water, because if this goes too high, it's gonna boil, and this is one of the states of the matter, that is have three: solid, gas, and liquid. We have the fourth one, that is plasma, but this is not part of the stage. We have three difference, that is solid. Well, we reach this kind of material when the water or the salt reaches the 0 degrees. But if we need the gas, well, this is more easy because you need to put temperature high, and when this reach the 100 degrees, it's gonna boil. We have different kind of topics in this stage: that thermal expansion or heat transfer. The heat transfer is when, for example, you have I don't know, like water, and you put an ice in the water. So the heat transfers to another part, and we're gonna have that our water is gonna be more cold thanks to the ice. And we have another kind of topics that we use every day. Well, my name is Fernando. Thank you so much.
Hi, I'm Max, and I'm going to talk about physics, stage 3, electricity and magnetism. We see a lot of things in this stage, like Ohm's law, Coulomb law, and household circuit, but I'm going to talk about specifically electricity energy source. So what are the most common electricity energy source? The most common is the mechanical energy. As you can see, the generator have inside a bands and chains that are moving, and this movement is converted to mechanical to electricity energy. Another type of electricity energy source is the chemical energy. This chemical energy you can find it in batteries. These batteries, in an example, you can put the batteries in a toy car, and when you activate the switch, the circuit that have inside the toy car put in contact with the battery, and this do that the chemical that have inside the battery liberates and make the chemical energy to electricity energy. The last type of electricity energy source that I'm going to talk is the wind energy. This wind energy is worked with a wind turbine. This wind turbine is made of a blades, the generator, and obviously the wind. So, how this really works? When the wind hits the blades start moving, and this movement activates the generator that have behind of the blades. So, if you can see, the main energy is the mechanical energy. Only that the wind is hitting the blades, that the blades is making the mechanical energy. So the main energy is the mechanical energy, but in fact it's wind energy. So finally, with this wind hit the blades and the blade starts moving, the generator starts to move, they change the band that I already said. So this is how the wind energy transforms to mechanical energy, and the mechanical energy transforms to electricity energy. So this is all I have to explain. Thanks for your attention.